Okay, so there's actually two questions here. You're comparing these two circuits. This is question 2. This is the touchy-feely 2. There's two questions here. You're comparing the circuit on the left and the right. So let's look at the circuit on the right. So the question tells you that you are moving VI minus and VI plus is a fixed voltage. And let's just look at V out plus, because on the circuit on the left, the load is diode connected, which means there's really not much gain over here, because a diode connected transistor has a resistance of 1 over GM. So this side doesn't have much gain. Even if the current changes through it, V out minus doesn't change much. So let's compare V out plus and V out plus on these two. So first, let's move V in minus up. That means the current through VI minus goes up. Okay. And there's actually two pieces that you have to put together to get this answer. So I am going to do the most useful piece first, and that is if the current through VI minus goes up. Remember, this is a diff pair, so the current through VI minus plus the current of VI plus has to equal the tail current source. Okay, so if the current through VI minus goes up, then the current through VI plus has to go down. Okay, so if the current through the right side goes up, the current through the left side has to go down, so it still sums to the same current. Okay, so if the current through VI plus goes down, then the current through top left transistor, I don't think there's enough space to write transistor, so we'll write trans, also has to go down. There's no place for the current to go, so if the current through VI plus goes down, then the current through the top left transistor goes down. Okay, and you can just write arrows here. I'm writing, let's see, did I do that? Okay, so if the current through top left goes down, then current through VI plus goes down, current through, okay, then VBE of top left goes down. Okay, so the current through the top left goes down, the VBE goes down. Now, the one on the left is diode connected, and the one on the right just receives whatever this diode connected connection voltage goes to. So the one on the right is kind of the recipient of the voltage generated by the transistor on the left up here. Okay, so it has no say about its VBE. Whatever happens to the VBE on the left also happens to the VBE on the right, just because the transistor on the right is just watching this voltage. It's the one on the left that's actually generating the voltage. And when you diode connect, that's what happens. When it's just going to the base, then the base uses whatever voltage comes to it. But if it's diode connected, it's generating a voltage. So if the VBE of the top left goes down, the VBE of top right also goes down. Okay, that's part 1, and now I'm going to do part 2 here. So this is kind of takes a break here. That's not a very good line. but gave it a try. So that's part one. Now let's do part two. So we have, let's try to stretch this out. Right? So we have VI minus current up, and you have that in a at step 2 here. So if VI minus current goes up, then current through top right goes up. But wait a minute, you turn down VBE, but the current through the transistor on the top right has to conduct more. So this transistor, there was less current going through this top left transistor, so it turned down its VBE, and the transistor on the right has to use that VBE. It's just the recipient of the base voltage. So its VBE went down, but it has more current going through it. So the only thing it can do, its VBE, it has to depend on this VBE, which has gone down. The only way it can turn up its current is to change its VCE. And because VBE got turned down, it has to change its VCE even more. So it's two things here. VBE down plus current up for top right. What happens is VCE of top right must move a lot. Okay. Okay. So let's look at this second diff pair. Notice that this isn't diode connected. The top left of the second diff pair is not diode connected. It's getting its voltage from V bias. So even when the currents change, the VBEs don't change. On the left, when the current changed, the VBE changed in the opposite direction that the current changed. So the VBE got smaller when the current increased, but the VBE would have gotten bigger if the current decreased. So either way, this top right transistor has to make its VCE change more because of the change in VBE. But over here, since you're just sending a bias to the top right transistor's base, the VBE stays constant and VCE just changes its normal amount. And that's why the amplifier on the left has better gain than the amplifier on the right.